So this may be the first video of mine that you're watching, and if that's the case, I just want to give a brief introduction. That is, these are practice exam questions, and what you would typically do is work them on your own, and then look at the answer key that I've posted in Blackboard. And then if the answer key doesn't make sense, or there's a certain part of the process a little bit unclear to you, then you watch the video. And so I would expect that you wouldn't necessarily watch every single video, but you use it as something you do when you're studying for the exam, just to make sure you understand the concepts. So I will start off with question 1, fit an exponential curve to the points. So if you recall, you could fit a line to 2 points, but in this case we're going to fit an exponential curve to 2 points. So there's some similarities and there's some differences. It's actually quite a bit easier in some ways because there's not much calculation. You just dump everything into the formula and you're done. So let's talk about what the parts of that formula are. Okay, so let's say F is the name of the formula. Let's let this be X and Y. Okay, but this X1, actually I'm going to make them time, not X's. Okay, this is your start time. And here's your original quantity or amount. And what's important here is I want to know what the growth ratio is. And that's going to be our new amount over our original amount, and I want to know what our time step is going to be, and that's going to be T2 minus T1. So those pieces will help us just dump everything into the formula. You're going to start with your original amount, so this would be like Y1, and then you're going to put the growth ratio in here, Y2 over Y1, and then up here you got an exponent, which is a fraction, and the numerator and the denominator both have minus in them. That's not a divide, that's 2 minus signs. You want the time step in the denominator down here, and you want t minus the original time in the numerator. The many problems that you do are simplified, and some of the structure gets lost. Let's just dump everything in and see what happens. So we start off with 5. And the growth ratio is 7.5 over 5. We will simplify that, but for now let's just dump everything in. T minus, so T, this T, let me just color it for you. There you go. That T is different. That's the actual variable T, as opposed to all these other little letters and numbers that are floating around, which are actually values we're getting out of the problem. Okay, T1 is our start time, and that's 2. And let's see, T2 is 3 and T1 is 2. So let's go ahead and simplify this down. Okay, 7.5 divided by 5 equals 1.5. And then you have T minus 2, because 3 minus 2 is just 1. So there you have your exponential curve that fits the points. Now it says find a logarithmic curve. Oh no, what do we do? Well, I'm doing this as a pair. You notice I just switched these guys around. Up above the exponential curve is 2, 5, and down below the logarithmic curve is 5, 2. I just breathe a little sigh of relief there. See, I just switched those around. So what's going to happen is I'm going to have alright. Doesn't work perfectly. Let's see. There we go. So we have the line y equals x, and I'm going to try to sketch the exponential curve. So 2, 5 is going to be somewhere over here. 3, 7.5. It's going to go something like this. Okay, kind of a bad drawing, but whatever is over here there's going to be a similar thing over here, and this is going to be the exponential curve. I mean the log curve. This one is the log curve, and this is the exponential curve. Okay? So if I want to find the log curve, it's just the inverse of the other one. So I'm just going to put t over here. This is the same set of steps we always go through when we're just trying to solve for an inverse. Swap the two variables and solve again. Okay? So I'm going to, to find an inverse, this is for any inverse, I'm going to swap the variables, solve for obviously the one that isn't already solved for. Okay, it's pretty easy. Okay, so but now what do? Let's see. Well, we got to isolate that y somehow. So at least we divide by 5 on both sides. I'll go ahead and take the natural log of both sides. That's the important thing. I'm going to do this out longhand just for the sake of being complete. But that step you could skip. All right. When take the natural log, the exponent gets to jump down out front. Don't forget to put that in parentheses. All right. Now what? Well, just nothing to it. Just keep crunching through. I was wondering if there was a clever way, but there really isn't. Okay, minus 2 natural log of 1.5. Then let's see. Just keep working it through. See, in class, I'd prompt you guys to do this. Da, 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 da. I seem to feel like there must have been some kind of shortcut that I'm missing. Maybe not. Okay, so y equals natural log of t over 5 over natural log of 1.5, and then you're just going to add 2 to that. Any other questions? I was supposed to plot them together, but I already did. So, right, so that was not the efficient way to do that. I should have just divided both sides by natural log of 1.5. You see, because I multiplied it through, and then I had to get rid of it again anyway. So, other than that, yep, that happens sometimes. If you go see my practice exam, I did it more efficiently. But this happens in a real exam situation. You can go ahead and do something and then say, oh, that was kind of stupid. But it doesn't matter. You still get to the same place. And in that case, it's not worth going and changing it, as long as you get to the right place. Okay. Happy studying.